So we have these incredible general-purpose AI models that are amazing at, well, general stuff. But what happens when you need one to be a true specialist in a really specific field, like chemistry, without having to spend a fortune retraining it from the ground up? Today, we're going to look at a brand new technique that might just be the perfect answer. And this is really the core question, isn't it? You've got an AI that knows pretty much everything on the internet, but you need it to understand the super niche, complex language of, say, molecular properties. Just retraining it is wildly expensive and takes forever. So how do you give it that PhD level knowledge without the PhD level price tag? Well, the go-to solution for this has been a pretty clever technique called Retrieval-Augmented Generation, or RAG for short. The best way to think about it is like giving a brilliant student an open book exam. Right before they answer a tough question, you slide them a few pages from the exact right textbook that has all the info they need. That's what RAG does. It finds relevant examples and shows them to the AI along with your question. Now, it's a great idea in theory, and it definitely works up to a point. But as researchers started using it more and more, they realized this popular method has three fundamental and honestly super frustrating flaws that were really holding it back. First off, it gets really expensive, and it gets expensive fast. The technical reason is that the more text you feed the AI, the more it has to process, and the computational cost doesn't just add up, it grows quadratically. It's like a taxi fare that doubles every single block you drive. That's how quickly the cost can spiral out of control. Problem number two, it's not always as accurate as you'd hope, especially in these highly specialized fields. Research shows that good old RAG can give pretty unsatisfactory results when you're dealing with complex, new data, like trying to predict if a molecule is going to be toxic. It just struggles to apply the examples it's given, which, is the whole point. And then there's the third problem, and this one might be the most maddening of them all. It is wildly unstable. Get this, studies found that the AI's performance can change dramatically just by shuffling the order of the text examples you give it. Can you imagine getting a different answer to the exact same question just because you changed the page order? For anything that needs to be reliable, that's a total deal breaker. So you're facing these three massive hurdles: cost, inaccuracy, and instability. What do? Well, researchers developed a brand new approach specifically designed to tackle all three. So let's meet the hero of our story, Multi-Head Attention RAG, or MHA-RAG. And this slide, right here, shows you the core genius of MHA-RAG in a nutshell. On the left, you see the old way, feeding the AI these long, clunky, raw text examples. But on the right, you see what MHA-RAG does. It compresses all that information into something much more elegant and efficient called soft prompts. It's literally the difference between handing that student the whole textbook versus a perfectly condensed one-page cheat sheet. So what are these soft prompts, really? Well, instead of actual words, they're these compact, learned representations of the original text. All that information gets encoded into a small set of numerical vectors. And because these vectors are so short and tidy, they are way, way more efficient for the AI to handle, which immediately starts to solve that big cost problem. Here's how it all comes together. First, just like normal RAG, it grabs the relevant examples. But then, and this is the magic trick, it uses something called a multi-head attention mechanism. You can think of this like a team of different specialists, all reading the same document. One head might focus on key definitions, another looks for relationships between ideas, and a third pulls out the numerical data. By working together, they create a much richer, deeper summary that captures everything important. Okay, so the theory sounds really cool, but does it actually deliver? Well, the data from the research paper is in, and it's not just a win, it's a clear triple win. MHA-RAG delivered on every single one of its promises. First up, let's talk accuracy. Across a bunch of different tests and models, MHA-RAG gave an average performance boost of nearly 20 points over standard RAG. Now, that is not a small improvement. That is a massive leap forward in getting the right answer in these really tough, specialized areas. So that inaccuracy problem? Yeah, I think we can call that one solved. Second, the cost. And wow, this chart really tells the whole story, doesn't it? You see that huge bar for RAG's cost on the left, and then that tiny little bar for MHA-RAG on the right.
By using those super efficient soft prompts, MHA-RAG slashes the computational costs by a factor of 10. A 10x reduction is an absolute game changer. The expense problem? Solved.
And finally, stability. Remember how maddening it was that just changing the order of examples could mess everything up? Well, look at this table. For standard RAG, you see the performance variances all over the place. But for MHA-RAG, the standard deviation is 0. A perfect 0. That means it gives the exact same high-quality performance no matter what order you feed it the examples. That infuriating stability problem, completely solved.
So, let's recap. We have a way to teach AI that's more accurate, 10 times cheaper, and perfectly stable. Why is this such a big deal outside of a research lab? Well, this has absolutely massive implications for the future of specialized AI. The real-world impact here is just profound. It means it suddenly becomes way cheaper and easier to build expert AI assistants for basically any field you can imagine. It brings rock-solid reliability to critical areas like medical diagnoses or chemical safety analysis. This could seriously accelerate scientific discovery in medicine and chemistry. And ultimately, it just makes this kind of advanced, specialized AI way more accessible to everyone, not just the big companies with massive supercomputers. So, this leaves us with a really exciting question to think about. What kind of new tools, what new discoveries, what kind of assistants can we create when the barrier to building an expert-level AI comes down this dramatically? What happens when this power isn't just available, but it's affordable and completely dependable too? When you get right down to it, MHA-RAG isn't just some minor upgrade. It really feels like a fundamentally new blueprint. It's a smarter way to teach our most advanced AI, and it's paving the way for a future where expert intelligence can be deployed anywhere, for any task, both efficiently and reliably.